Look at this situation. This is diffraction, as you can see, gap in a barrier, water wave passing. So is a diffraction. Just check the lambda. The lambda is here, lambda is here. That's the same lambda. So speed is the same, frequency is the same, wavelength is the same. But you see that the center is almost straight. So this is less diffraction, less diffraction. Okay, which change will increase the diffraction of the wave as it passes through the gap? So this diffraction, as you can see, lambda is there, the gap width is this much, so that's much bigger, slightly bigger. You want to make it, if you make it equal, then it spreads out. It's if the wavelength, see this size and this wave is approximately the same, this distance and this distance approximately the same, then you will have a much larger diffraction. So you have much larger diffraction there. So if you want to increase the diffraction, increase the amplitude, no, nothing to do. Increase the width, which reduces diffraction. Diffraction decreases. It could be, don't fix this in your head. It depends on whether lambda is comparable. But if you increase the gap here, then the gap is going to be much bigger than the wavelength. So therefore it cannot be. Reduce the depth of water. If you reduce the depth, that means it's shallow. If it's shallow, then the speed decreases. When the speed decreases, the wavelength decreases. So there is some effect when you reduce the speed. Shallow water, the speed is lower, same frequency, lambda decreases. If the lambda decreases, now the wavelength is smaller, but the gap is still bigger. So it's again going to be less diffraction. So that is of no use for us. Increasing the width also, diffraction decreases. You want to increase the diffraction, that's the question. So if you reduce the frequency decreases and no change in the speed, V is constant. If you have these two situations, then you know that lambda equals to V over F. That means frequency decreases, wavelength increases. Now when the wavelength increases, now you'll find that these waves now are further apart. So if the waves are further apart and you have a big gap, earlier the waves were very close to each other, but now you have a bigger wavelength. So now this spacing and this spacing is comparable, so you have more diffraction there. So that would be the answer. 33, okay, you want to find which diagrams are correct. Passing through the optic center goes straight. Parallel must pass through the focus, so it has to pass through there. Since it did not pass through there, that's wrong. Next one, passing through the focus becomes parallel, so that's correct. So 1 and 3 are correct. That's the 3. These were the 3 rays that we need to consider. If it's parallel, passes through the focus. If it passes through the focus, becomes parallel. It has to become parallel just after hitting the lens. Which list shows regional electromagnetic spectrum in order of increasing frequency? So frequency has to increase. The highest frequency in the spectrum was gamma rays, and gamma rays should be X-rays just before that. So we know that this is increasing frequency. That means it has to go this way. So X-ray should be the last. So we know that it's either C or D. Then you should know that ultraviolet after, just beside X-ray is ultraviolet. So answer C. I think the answer is somewhere earlier. You just need to check properly. The sun emits infrared radiation and light. So visible light and infrared. Light reaches in 8 minutes. Infrared also should take 8 minutes because it's the same speed. Which row gives correct information? Infrared is closer to microwaves and radio waves, which is longer wavelength. So it has to be longer wavelength than light. Again, it's A. Okay. 2 beams of light are both the same color of red. One beam is traveling through air, the other beam is traveling through water. Each beam has a different brightness. So same red color, so frequency is the same, wavelength is the same. No, wavelength depends on the speed. Frequency is the same. One beam is traveling through air, the other beam is traveling through water. So you have one red is going through air and one is going through water. Since the speed here is going to be greater than the speed here, so the speed in air is greater than speed in water. So the lambda in air is greater than lambda in water because the frequency is the same. Which quantity is the same for both sets of waves? Amplitude cannot be the same because it has different brightness. Frequency is the same. Okay, speed cannot be the same because speed in air is greater than speed in water, and if speed is different and frequency is constant, then wavelength cannot be the same. Okay, which statement, answer is B. Which statement of electromagnetic wave is not correct? They have the same speed, they transfer energy. They can't have two speeds. Air and vacuum is the same speed, approximately the same speed, slightly different, but same speed. They cannot, this is the speed of sound in air, 340, because the question is electromagnetic waves. And the one that is not correct is this, because that's the speed of sound. They are transverse wave. They transfer energy. All waves transfer energy. Always the travel can transfer energy. Which statement compares radio waves and X-rays? Same speed in vacuum, same speed in vacuum. That should be correct. Radio waves have longer wavelength. That's the longest wavelength. Again, electromagnetic spectrum. Now, for these two rays, this ray and this ray are parallel to each other. That happens when the angle of incidence here and the angle of refraction here are the same. Angle of incidence at boundary 1 and angle of refraction at boundary 2 should be the same. Mathematical reasons are there, some conceptual reasons are there. We can look at it in different way, but the idea is this should be parallel. For them to be parallel, should go like that. We'll look at it in a different way, probably in class, if possible. Maybe I'll do another section for this. The next one, last question. A thin converging lens in a camera produces a real image. So it's a converging lens that's in a camera, photosensitive surface as shown on a photosensitive surface. So that's where you have the sensor of your camera. At which position is the image of the top? So you want to find the image of the top. So you know you need to take the rays from these. Parallel ray going through the probably that's the focus there. So it reaches here. Another ray passing through the optic center goes there. That's where the ray intersects. So the answer to that question is C. What about if the question was instead of top, they had written the word bottom? So the bottom is here, so that would be for the bottom. Okay, that will be for the bottom, that will be for the top, but we don't want for the bottom, we want it for the top, and we want it for the top as shown. That's the question. So the answer is going to be C. Okay, I hope you can go through the questions again. These are just sample questions. I'll try to get more answers for the other MCQs that I've given, and some subjective we'll try to see how to do.